Now we go to the last discounting family, the unit invariance family. And you notice we have fewer discount families that we treat than risk models that we did. That is representative for the field. In fact, in intertemporal choice, I think it's an underdeveloped that field. In many respects, the unit invariance family to present now is the only one that can satisfy some satisfactory conditions, that has a potential of working, but is still new, it's not well known. So here I think a bit more work to be done. Let me explain how the unit invariance family works, and then I'll explain more what I just said. Again, we're going to develop the family a bit in the spirit of what we did before. We're going to allow for violation of stationarity. We're going to look at particular ways in which it is violated, particular patterns that could be found in such violation. And if they are found, then it turns out that a particular family, we can get a foundation of the family. So we're going to do that way of approach again. And I'll explain the pattern in violations of stationarity now to you. Imagine we start again from these indifferences, a small amount immediately now is equally good as a larger amount a bit later. And we're going to assume also that if we postpone the whole thing by d, so you get sigma not at time point 0 but at time d, and to have an indifference here we have a bigger time duration here. D prime will be bigger, of course, because lambda is bigger. So I now denote it by d prime. That's more convenient for the purposes now. Anyway, we start from such an indifference. And you already know constant impatience, say d prime would be d plus L. That was stationarity constant impatience, but we're interested in violations. We're going to allow for decreasing impatience. Decreasing impatience made you more impatient. Here you're willing to wait longer. D prime is bigger than d plus L. We surely want to allow for such things. But an important point I'm going to explain later, really, unlike all the families we've seen so far, here we do not commit to decreasing impatience. We also allow increasing impatience. That would mean here you are more impatient and d prime would be smaller than d plus L. It's important, I think, to allow that, even if it's not prevailing. Discuss more later. Anyway, let's go on. The unit invariance family, the pattern of violation. Let me first show it mathematically, then interpret how it goes. We're going to look at changes in the unit of time. Imagine all the time durations will be multiplied maybe by 12, whatever. For instance, if these were months and we change them into years, means we multiply all the time durations by 12. We're going to look at such things and then things that happen. We want to study indifference patterns still, something about them. So I write it. Imagine here this is quite like we saw above, only all the time durations were multiplied by mu, can be any positive. If it's 12, then it means we changed months into years. One thing is we want to study indifferences, but if here we multiply the time duration by 12, so here we get 12L, 0, then need no more be an indifference. Well, we want to say something about indifference, I'll explain more later, and therefore we're going to replace the outcome lambda by an outcome lambda prime, such that we have indifference again here. And then unit invariance says, if we do all these things, we take care of having indifference here again, we multiplied all the time duration by mu, then we should get that indifference also. Sort of invariance with respect to change in time unit if the proper outcomes are arranged. That's the condition mathematically. And you can imagine that if I put it like that, you don't really see an intuitive idea in it. So I'll talk a bit more about these indifferences to explain the idea underlying it. For this purpose, we first look at the indifference here, and we say, we can interpret as meaning, imagine we say to the person, look, you can get sigma time point 0, but we're going to delay until time point L. Well, you don't like that. So you want an extra high payment to make up for that. How much more should we pay you for you to accept this delay by until L? And imagine the person, I want lambda bigger than sigma, so much I want, then I'm indifferent, then I'm okay with that delay. So we could say getting lambda instead of sigma is a sort of willingness to pay for delay. That's just the interpretation of this indifference. Now, with that willingness to pay interpretation in mind, We look at this indifference. Here they can say, well, time point d you get sigma, but we're going to postpone until a time point d prime later than d. And we ask you, how much more money do you want to have to make up for that delay? That your willingness to pay for the delay, so to say. And imagine here we have the same lambda as we saw before. So your willingness to pay for delay is apparently the same from 0 to L as for d to d prime. So in that sense, the time interval 0L and the time interval d prime, they are matching in the sense that the same willingness to pay is involved. So in a way, it feels like they are the same sort of delays, equally bad delays. That's one way of interpreting these indifferences. Now, with that interpretation in mind, we look at the differences here. Here, a similar story. Imagine the payoff time point 0 is delayed until mu L. How much more money do you want to have to accept that? And you say lambda prime. So lambda prime instead of sigma indicates the willingness to pay, for you to accept that time delay. Well, if we have this indifference, and we also have the indifference here, then here we same story. It's delayed from mu d until the bigger mu d prime, and you say I want lambda prime instead of sigma to offset that delay. For these two differences, we can also say the time interval mu 0 until mu L has the same willingness to pay for delay as mu d until mu d prime. So in that sense, the two time intervals here, mu 0 to mu L and mu d until mu d prime, are also matching. Same willingness to pay, to wait. So in a way, they are the same, equally bad when it comes to being a delay. So with all that story, we can say if intervals are matching regarding that willingness to pay, that must be maintained if we multiply it by the same positive constant, for instance, by 12. So if from such indifference we say waiting from 0 till 3 months is equally bad as waiting from 8 till 12 months, then here we can say waiting from 0 to 3 years is equally bad as waiting from 8 to 12 years. So the same story, but only year instead of month. This condition is reasonable if people perceive time in a proportional manner, which in this context of indeterminate makes a lot of sense. So therefore, empirically, it's not a bad condition. It's a reasonable condition that people have such a proportional perception of time, and then this condition is reasonable. Anyway, so with this, I already said these things. It turns out, Ebert and Pre, like paper, they proved that condition that I just showed you, that this perception of willingness to pay is invariant under changes in unit of time, holds if and only if the discount family has the following mathematical form. So here there are two parameters, delta and r, and the function will be of this kind. It's quite like constant discounting, only now we take the power delta. That delta was not there in discounting, it was just the rate only. So in that sense, this family generalizes constant discounting. That's a unit invariance family, and R and delta positive. Here we have R works much like it did in constant discounting. Yes, the bigger R, the more impatient you are, but it does not really affect if you have constant stationarity or whatever, those kind of things. This R is like the traditional parameter. Here, delta is the new parameter that captures how much your impatient is non-constant. The smaller delta, the more your impatient is decreasing. That can be seen to be the case. This model is quite like if the person is doing constant discounting but is misperceiving time. Is not perceiving time in the linear way that it is, but is perceiving time as a power function, as t to the power delta. That's one interpretation of this family. This is constant discounting. Only the person is misperceiving time, is perceiving time by a power function. In fact, there are many studies in psychophysics that power function perception is very realistic. So in that sense, also psychologically speaking, this is a reasonable formula. This can well capture things going on in the human perception, human minds. Anyway, if delta is smaller than 1, then time is being transformed concavely. And it can be seen that we then get decreasing impatience. I will not explain, but you take my word for it. But delta bigger than 1, we have increasing impatience, the opposite. And this family is deliberately allowing for it, and I'll explain later why I think that's a good thing to do. There's in fact, also I worked on it with some co-authors. We argue that it would be good to also allow for delta smaller than 0, but let's not get into those details right now. But surely, in my opinion, this is the most promising family existing today, and more promising maybe developed by young people like you guys to come. Now some graphs to illustrate these functions. First we start, I'll always be taking r equal 1. So just keep that fixed. The parameter that is traditional one, degree of impatience. Here on the line, it should be curved, it should be smooth. This is the constant discounting family. And now I put up family function where we take the delta different from 1, so that it deviates from constant discount, it gives something new. And this delta is such that we have indeed decreasing impatience, the prevailing broker finding. If we make delta even smaller, we even have more decreasing impatience, and the curve shows it. But in this family, we can also have delta bigger than 1. We do allow it, and then you have increasing impatience. It's happening here. In the beginning, you are more, well, here you are less impatient because curve is above, but here you are more impatient, curve is below. Your impatience is increasing. So that's a typical thing of this family, and very deliberately, this is incorporated. Here's an extreme case, delta equal 10, very strong. This is what the family looked like. Now, before discussing it very much, first just some simple calculation to illustrate. Well, you've seen them many times before, it's getting very routine now, so you know how they can be interpreted, but let me do it still one more time. So the usual notation that you saw before, we're going to take square root utility, which is perfectly quite okay, a reasonable value r, delta 0.5. So, and then we do some calculations. First, the present value of the dated outcome 0,100 is of course 100. Now we do the calculation for the second, that will give a smaller value. Here the discounted utility, and you see 0.9. So here's only 4 months and already 10% discounting. So in that sense, this family is quite accommodating this presence effect, that immediately you have a lot of discounting in the beginning, which is empirically realistic. The present value is more informative, is 84. So 105 in 4 months is equally good as 84.3 right now. And here already the presence effect, the immediacy effect is quite strongly hitting in already, making this already small. It will also hit in for the 2-1 to come next. Well, it's getting routine for you now, I assume, I hope. So here I calculate the discounted utility of this dated outcome. And you see here's quite a lot of discounting because the presence effect pushed everything down. But after not so very much happening, later the discounting doesn't increase very much anymore. That becomes clear if I do the next, well, here's the present value. If I do the next calculation, and here it is quite 52 months instead of 48. So of course the weight is less, but not much less. There's not much impatience, is not very weak here, but it has decreased a lot. So this is an example of a member of the family is still the usual decreasing impatience, and we see it happening here. Anyway, you know the pattern by now. We have these three are all hit by the presence effect, as it should be. For these two, it's the same, so it doesn't affect the preference very much anymore. So you're quite patient here. You prefer the big amount of money. But here, well, this one is hit by the presence effect, but this one not. So the upper one is privileged, as you've seen it many times. So because here the upper one is privileged and here not, that's why here you have the preference reversal. You prefer the upper one. Here you prefer the lower one, and fitting with psychology of prevalence effects, all these things, fitting again with your perception that many of you said, waiting 4 years or 4 years or 4 months doesn't matter much. All these plausible things are captured by the family in the ways it should be. So good family. Anyway, now some more discussion of, I end now this chapter with a general discussion, and I'll continue discussing what we just saw. In general, all the models that you saw can accommodate the decreasing impatient, which is empirically prevailing, which is strongest at time is 0, and all the models can handle that. That's the first purpose that they all were developed for, so little wonder. Quasi-hyperbolic, already said, is most popular today, especially because it's retractable. But it's too crude for real, it's too crude to do real, very serious business. Janus hyperbolic is more refined, but it hasn't been working very well. It doesn't fit. That also does some analytical problems. So there's not. Anyway, they share a big drawback. They can only accommodate decreasing impatience. Now, I already told you it's empirically is the prevailing finding, but still you should be able to incorporate increasing impatience. You can compare that with risk attitude. Empirically prevailing is risk aversion, but still there's so much risk seeking and so many individuals. You should also be able to accommodate risk seeking, even if it's the minority phenomenon, but it happens so much you can't fully ignore. And that is also the case with intertemporal choice. There's much increasing. I already said decreasing impatience is prevailing, but there's so much. Every study, you have a heterogeneous group of subjects. There's always a considerable part of the subjects who do have increasing impatience. Surely not everybody has decreasing. So if you do data fitting and 1/3 of your subject, you can't do data fitting, that doesn't work. So really you can't do this. Even there have been quite some studies where not only many, but where the majority of subjects have increasing impatience. So overall, decreasing impatience is prevailing, but in many situations, particular situations, there's even more increasing than decreasing impatience. And if you think about it, it's not so counterintuitive, because in many situations, waiting a little bit is no problem, and wait 5 minutes more, okay. But if you already waited an hour, then you don't want to wait 5 minutes more, then you're fed up of it. So then you have increasing impatience. In many situations, this is very plausible. And a literature search shows already many studies find increasing impatience. It is so widespread, even if it is the minority, it's too widespread to ignore. So it's simply families need to incorporate that. And that's why the unit invariance family is the only one I think that has potential to work in the long run. But it's new and we don't know it very well. Maybe it will also have drawbacks. Maybe just simply a better family should be developed. So that is a research topic where young researchers can do good work. Okay, that finishes chapter 5, and then we go on to chapter 6, welfare evaluation, but that will be the next meeting. This is the end of the meeting, the second meeting.